Let us first of all discuss about scalar quantities. So the quantities which possess only the magnitude are called scalar quantities. Suppose the mass of a person is 94 kilogram. In first case, the person stands up on the weighing machine and the reading of the weighing machine is 94 kilogram. Now he lays down on the weighing machine. Even then the reading will be 94 kg. And if he stands upside down on the weighing machine, even then the reading will be 94 kg. So this tells that actually mass does not have any direction. So whatever is the direction of the body, so the mass comes out to be same. Let us take another example. Suppose we have 2 liter of milk and we put it inside a bottle. So this first case actually represents when the bottle is erect, and this is the case when the bottle is actually lying on the floor. In both of the cases, the volume of the milk that is contained in this bottle will not change and it will remain 2 liter. So this also tells that volume, just like mass, is also a scalar quantity because it has no effect of direction, or in general we can say that volume does not possess any direction. So volume is a scalar quantity. Let us take another example. We know that we when ride on a vehicle, then it has a odometer. Suppose at any time the reading described by the odometer is 23470. Actually this reading tells that till date the vehicle has covered or traveled a distance of 23,470 kilometer. But this reading does not tell anything about the direction in which the vehicle has traveled. Hence, we can say that distance is also a scalar quantity. Let us take another example. On any two-wheeler or four-wheeler vehicle, we also have a speedometer in the instrument cluster of the vehicle, and right now at the instant when this figure has been drawn, it is giving around 100 kilometer per hour as the speed of the vehicle. So this speedometer is giving us the information that the vehicle will be covering a distance of 100 kilometer in a time of 1 hour, but it is not telling us any direction in which the vehicle is moving. It is an information without any direction. So therefore speed is also a scalar quantity. Similarly, entropy, which is written by the symbol S, it is defined as the degree of randomness of a system, or it is also defined as the total number of ways in which the system can use the energy given to it. This quantity is also a scalar quantity. Other examples of scalars are distance, area, volume, angle, counting of any numbers like 2, 3, 4, -1, -2 are rational numbers, are real numbers, all these are scalar quantities. Speed, current, mass, energy, work, heat, temperature, pressure, intensity of light, loudness of sound, entropy, etc. All these quantities are the scalar quantities. This does not have any direction. Let us now turn our attention toward vector quantities. Those quantities which possess magnitude as well as direction are called the vector quantities. Let us take an example. Suppose a vehicle is moving at an angle of 30 degrees north of east and it is traveling in such a way that the distance covered by it in 1 hour is 100 kilometer. Let us draw the diagram of this situation. So in this situation, this direction is actually east and this is north. As per the question, the vehicle is moving at an angle 30 degree north of east. So what we will do, we will place our protractor along the east direction, and from there we will draw an angle of 30 degree toward the north direction, and then we will draw a line toward this direction, and this direction will be actually 30 degree north of east. However, this is not the only way in which we can represent this direction. We can do the otherwise also. For example, if you want to go with along this direction, but you want to measure the angle from north instead of east, then you can write your protractor along the north, and then you have to draw an angle of 60 degree toward east. So please remember that 30 degree north of east or 60 degree east of north represent same direction. However, if we draw 30 degree south of east, please remember this is the south direction. So if we place our protractor along the east direction and draw an angle of 30 degrees south, then you can see the arrow marked here will take you in a different direction. Therefore, 30 degree north of east and 30 degrees south of east do not represent the same direction. So, obviously, we have now got the answer to this question. What tells the direction in this situation? So the answer is angle with some reference line or reference direction. So if we take the reference direction and as east, then the direction of motion of the object in this example will be 30 degree north of east. On the other hand, if we take reference direction as north, then the direction will be represented by 60 degree east of north. So this is the same reminder that I have just talked, that 30 degree north of east and 60 degree east of north both belong to same direction. However, 30 degree south of east and 30 degree north of east belong to different directions. So with this example we can make a conclusion that with the change in the reference line, the angle describing the direction may have a different value. Although the direction may remain the same, but the value of angle described depends upon the reference line that we choose. And another conclusion that we make from this example is that the velocity is a vector quantity, and please remember it becomes vector because it is possessing magnitude as well as direction. Let us see its statement again for better clarity. So see, this was the statement. Here 100 km distance is traveled in 1 hour, which gives the magnitude of the motion, and this angle 30 degree north of east, this information is giving you the direction. So in this example, the motion of the person consists of both information, that is about its magnitude as well as direction. So the magnitude of the motion with which it is moving, it is 100 km/h, and the direction of the motion is actually 30 degree north of east. So therefore this complete information containing magnitude as well as direction is called velocity, and velocity is a vector quantity. So another example that we will do here is to conclude that force is also a vector quantity. For that, consider the force acting on a freely falling body. Now if we take an object and it is allowed to fall freely, then these are the 5 directions that I have drawn. Direction 1, 2, 3, 4 and 5. This is earth. So there is a question that will arise out of these 5 directions that have been drawn. What is the correct direction toward which the object will fall down? And we all know, because we have studied these things in our high school classes, that the object will fall freely toward the center of earth. So the first direction will be the correct direction, which will be the force acting on this object and which will be responsible for the object falling on the surface of earth. So the force is taking this object in a particular direction, not in all possible directions. Hence we can conclude that force is a vector quantity. But please remember that the force which is acting on an object and it is tending to move the object toward the center of earth is called its weight. So here there can be another conclusion that just like force, weight is also a vector quantity. Please remember that there is a difference between weight and mass. The prominent difference can be the unit. The unit of mass in SI system is kilogram and that in CGS system is gram. On the other hand, the unit of weight in SI system is Newton and that in CGS system is dyne. So if we have this question, what is the direction of weight of every object? So the answer will be, it is always directed toward the center of Earth. So other examples of vector quantities are displacement, acceleration, velocity, force, momentum, that can be linear momentum as well as angular momentum, torque, surface tension, electric field, magnetic field, etc. Thank you.